Hello, I'm Martin, and welcome to Groundhog Graphics. This is episode 6 of Programming in C. In this lesson, we will be learning about the for loop. Let's begin. Let's go ahead and create a new project. And we will go with Console Application, double click it, and C. Project title, episode EP6. Next, defaults are fine. Finish. Go over here to sources on our main C file. As always, remove all of this. So now what I'm going to do is I'm going to pause the video. I'm going to write up a sample program, and then we're going to go through and I'll explain it to you. Okay, so we see this very simple program, and this is called a for loop right here. And the for loop has open brace and a curly brace, so this is the body of our for loop. Our for loop right here, before the first semicolon, it has count, which we see we've initialized count up here. So int count, and what it does is, we've declared count up here, but what it does is it initializes count to 0. So the very beginning of a for statement, actually in the for statement you have 3 different things going on at one time. This first statement here initializes a variable. It can be initialized to anything you want. The second spot right here actually tests for an expression to evaluate to true or false. So as long as count is less than 10, this for loop will continue looping. Next, we have count plus plus, which is incrementing our counter. Then, come down here, I have our getch right here at the bottom. Just in case you're not using code blocks, this will stop the execution from disappearing before you get a chance to see the results of our for loop. So let's go ahead and let's run this program. F9. There you can see it counts from 0 to 9. Now I'm going to hit a key, return us to the editor. We'll hit a key twice. So what the for loop is good for is it's good for counting. Okay, it's good for something that you have to do so many numbers of times. Now, you might be going, well, why do we need a for loop if we have a do while loop? Well, you're right, because everything that you can do with a do while loop, you can do with a for loop, and vice versa. They're completely interchangeable. However, you will find when you're programming that one or the other will seem more applicable to a particular problem. And this is a perfect example of a good use of a for loop. Now, a while loop could be testing for count, but it doesn't have the place where we can do an increment, and it doesn't have anything for initialization. However, that could all be taken care of outside of the parentheses of the while loop. But a while loop really may be more advantageous to use or more convenient to use if you were checking for like a specific condition to occur. Like, let's say we had a loop and it was looping over and over and over, and we wanted to wait until the user pressed the letter E on the keyboard. So we would say, let me go ahead and type that out. Let's see here. Let's go do and and we will say while getch not equal to the letter E, and we end with a semicolon, and print F looping. I'll put a \n, looping, and a semicolon. Now, I also noticed something here. I made a little mistake. I used getch, and so far we've been using getc. Getch we'll pretty much do the same thing that we were doing with get C. However, we will actually have to include another library to use getch. So let's go ahead and do that. Include conio.h, which stands for console input output library. Now that will handle getch. You can assign values like, count equals getch, and it will get a letter from the keyboard, much like getc does from the standard input. But I wasn't thinking about it when I wrote the program, and I just wrote down getch, which is what I normally am using. But anyway, so that clarifies that. Let's go ahead and look at this do loop. So now we have do and while, and it gets getch, and whatever is returned by getch, as long as it is not equal to the letter E, our loop will continue looping. So let's go ahead and see that in action. F9. Okay, so we see we have our first looping. I'm going to hit the letter, let's see, F, E. Oh, E should have exited. Yeah, let me go ahead and do that again. I just accidentally wasn't even thinking. Okay, so let's go F, I, J, K, L, Q, and it just continues on, and then I hit E, and then it exits. It didn't say anything or do anything special, but it exits. And then it went to our next getch, so it paused the output of the program. Now I hit another key, and we should return to the editor. There we are. So that's a good use of a while statement, checking for a specific condition. Not to say that if you're using a while statement, you might want to check for an expression like count less than 10. You might want to do that. But a good rule of thumb is if you have use of at least two of these places in this for loop. Like let's say you have count less than 10 and count plus plus. Maybe you're not initializing to 0. It would be a good use to use for. But if you were to say all you needed was count less than 10 and you didn't need the count plus plus up here, you didn't need the count equals 0, then it would be a good time to probably select a while loop or a do while loop. So that's kind of to give you an idea of where it might be more appropriate. Like I said, the for loop is excellent for counting. Now let's also look at, let's change our for loop and try something else here. Let's say count equals 10. And basically, like the for loop, and the same as the if, and the same as the while, as long as the value here is true, like if it was 1 or even 100, because remember, any non-zero value in C is true, this loop will continue looping. So let's count backwards and put count right here. And now let's go, instead of count plus plus, count minus minus. And now we'll count backwards, and you notice we don't have to evaluate this anymore. Count is we're just checking the variable, because as soon as it hits 0, it's going to tell the for loop that's false, and it's going to exit. But I'm going to get rid of our little do while loop, because that'll be a kind of an annoyance. So now let's go ahead and go with F9. Now we can see we've counted backwards, and it did not print 0. So, but it did print 10. So, what that also tells us, because it printed 10, see we assigned 10 right here at count. We realized that the first run of this loop, the very first time this loop executes, count minus minus has not taken effect yet. It has not subtracted 1 the very first time this loop has ran. So we know that in a for loop, the very first run of the loop will be exactly equal to what we have assigned to the variable. If we assigned it here or if we assigned it up here, whichever. Now, let's go ahead and go up here and put equal to 15. And now I can take this out of our loop, and we can still execute it. So let's go ahead and go with F9. There we go, 15. So it did the same thing. Let's go ahead and go back to the editor. Now, technically, if I want to, I can take this out too. And I could come down here and put count minus minus. Sorry, my phone's going crazy. Let's see here, count minus minus, and let's go ahead and execute with F9. And there we go, we have the same thing. So you can see that we don't have to have anything in these, or we can populate the entire for statement. It's entirely up to you and what you need. In addition to this, let's go ahead and let's put count equals 10 and count plus plus and count less than 15. Okay, so now we go up here, change this. We don't need to initialize it. Alright. So now what I'm going to show you is these curly braces for our for loop. These are also not required. This is the same, well, they're not required. If we get rid of this, they're not required for this one line statement. As long as you have like one line statement after a for loop or an if conditional statement or even a while loop, you don't need these brackets if you don't want them. Although, if you wanted to add something later to the body of your loop, you would then need to add those brackets and then put this inside of it. So it's up to you. You can enclose it in brackets or not. It's just entirely a personal preference. So let's go ahead and execute this and watch it work. F9. Let's see, 10. Count up to 14. There we go. Okay, well that wasn't that great. Let's count it from 0. Okay, F9. There we go, from 0 to 14. Perfect. And we see we have no brackets for a body of our loop. But this only works if you have one line. And that's our one line right here with printf. So now I'm going to go ahead and I'm going to put our brackets back. There we go. And if that was helpful, thank you. Thank you, editor. That was great. Let's see. Okay, now our brackets are back. So now I'm going to show you another little trick you can do with the for loop as well. Is we can combine, we can actually add more initializations in here if we want. And as within the if statements and our compound relational operators, we can add, of course, as many expression tests as we want inside this area with the logical and, or, and not. And then we have our counter plus plus, but we can even add more things in here. Let me show you what I'm talking about. Let's go ahead and put count down. Okay, so now I want to make count down. I put a comma, count down. Notice I put the capital in here. You may hear this referred to as camel case. Camel case is where you have a lowercase, begin with a lowercase, and then you separate your words with an uppercase letter, and that's sometimes referred to as camel case. So now we have count equals 0, count down, let's say we want it to equal 15. And now, if I want to come over here, I can, instead of count plus plus, I can go comma, count down, and I can go minus minus. And then, so we can see our output, count equals, and put a tab in here, 2 tabs. Oh no, look what I've done. Percent. Okay, so now I can put count down equals %d and \n for a new line character. And come over here and I put another comma and put count down variable. And now what we're going to do, what this line says now, is the for loop begins by initializing variables. It initializes count to equal 0. It initializes count down to then equal 15. Then our semicolon is now our expression test area. So now it will test to see if count is less than 15. And we don't need to test for the other expression because it'll stop when count hits 15. So then we can go over here, and our last is our decrement area, and we can go count plus plus, and we also do count down minus minus. Let's go ahead and execute this code with F9. And now we have count is equal to 0, and we have count equal to 1. I'm not sure why it offset like that. I'll have to look at that. But anyways, you can see count equals 0 and count all the way to 14, and then count down went from 15 all the way down to 1. So you can see you can add more things inside of your for statement with using a comma. The only difference, the only place you can't do a comma would be here with your expression tests, but you don't need to. Like if I want to do and count down is greater than 2. Okay, and that'll make our counter now stop a little short. But you see, that's the same as when we did our if statements and our while statement. And you see, there's a common theme in C on how we do our expression tests and how we use our compound relational operators, or logic operators, such as AND right here. Let's go ahead and we'll execute this right here to show you how it works. And count equals 0, count 15, and then you see it stops short because both of those expressions that were tested have to evaluate to true because we used a logical and since one of them proved to be false a little earlier than the other one, then it canceled our for loop. And you can see right here, count is less than 15, and countdown has to be greater than 2. Well, that stopped us then before we got to the 15 on our count. Now we can see that the for loop here, even though we can do this, it is looking a little bit more confusing doing it this way. And I probably wouldn't advise. I would, if you want to do a couple of initializations up in here, that's okay. You can do that, and you can definitely test for a couple of different situations up here for your conditional test. That's fine. But having your count plus plus and your count down minus minus, that's not totally necessary. We could always come down here, and do count down minus minus semicolon. And this for me, I think to a lot of people, programmers, it would just look a little cleaner because they can say, okay, you got a couple of initializations here. We're testing for these two possible conditions for count and count down. And then we have our one increment. Probably best to just kind of leave that increment area with one increment or decrement, or that's about it. I wouldn't add too much more to this. It just starts getting very full, and we don't want that. So we have count down minus minus. We can get the same results if we go up here and go to F9. Okay, count equals 0, count down 15, and we got the same results as we had before, and we are good to go. Now we can go ahead and come back, and now that's why I was like, why is that doing that indent? I got an extra couple of spaces in here. Alright, F9, now it should look better. There we go. Now it all lines up and looks fine. And that's about all there is to the C's for loop. Can't think of anything else we should add to it. So I hope that this little demonstration was educational. As always, thank you for watching, and I will catch you next time. Bye.